Hello everyone, my name is Mohan Sai Singham Sethi. Today I'll be presenting our paper for CVPR 2026 ReaGEN, that is Adaptive Generation of Structured Chain of Thoughts for Efficient Multimodal Reasoning. Coming to the background, existing reasoning approaches on the multimodal LLMs, to improve the performance, they either rely on costly inference time exploration or they require an expensive post-training of multimodal LLMs on that require like a large amount of curated COD datasets. So the idea of this paper is so we introduce like a new kind of paradigm, that is ReaGEN, which incorporates like a lightweight generator model that can be used on top of like a frozen multimodal LLM to adaptively generate like a query specific structured reasoning chains. So this can boost the reasoning performance while avoiding any additional multimodal LLM training and requiring like far less inference time compute than source-based methods. To train this generator model, we follow this offline COT evolution approach, where the idea is that the region like builds a query-specific COT trajectory datasets using this teacher guided search. So here a COT is basically a sequence of stages. So this could be something like first you ground, then you reason, then you verify, something like that. So every stage is defined by a fixed prompt and a JSON output schema. So to perform this search, we have like multiple stages. So the first one is evaluation. So initially we pass an image and query, and then we also have a set of initial seed initialized COT structures that we pass to the evaluation phase. So each candidate COT is executed stage by stage with the multimodal LLM, and we compute a prediction score for each candidate of COT with respect to the ground truth to see how good is the COT structure. Along with this, we also compute some intermediate outputs, for example, like stage outputs, and also we compute this cross attention maps. So we convert these attention patterns into like stage importance scores. So once we have these for every candidate, we have like a pool of candidates. So we select the top scoring COT structures with respect to the outputs and the importance scores, and then we convert these top into like a text-based feedback, top candidates in text-based feedback, and we just give it to the teacher to rewrite into like a new COT. So we keep iterating this until we have like a good pair of COT structures. So once we have this, we train the generator model. So we use like a lightweight 18 million generator model that will try to match this teacher generated search outputs. So basically the generator will take image query, attention maps, and also initial COT that can rewrite to a new COT structure that is similar to what we find during the search. And during inference, so at inference, so only the generator is invoked. The frozen multimodal LLM first executes an unseen image and image question pair with initial COT structure along with this cross attention. So we pass this COT and image query pair to generate this attention map, and then we also pass this COT structure, image, and question pair to the generator to rewrite to a new COT. So then we pass this COT structure to this frozen VLM to generate this output. So the generator can have two type of modes. So one is single pass where we just directly call the frozen VLM once and then we generate the output, or we keep iteratively calling the generator to refine the COD structure over and over again. And coming to looking at the scores, so here is a comparison of brief comparison of our model versus other approaches. So here is performance with respect to the proprietary models, and the benchmarks here are with respect to vision and math benchmarks. Looking at so we see that the proprietary models, even though the model sizes are far bigger, we see that the performance are somehow like weaker But GPT 4.0 on some benchmarks seems to be have like a superior performance, but then we see that some benchmarks still kind of fail even with proprietary models. So we pick for our comparison, we pick Quen 3 VL 4 billion model. So the direct answer is basically just answering with respect to um, um, just directly answering without any reasoning, and CVOT is with reasoning. VREST is search based approach, and this is our approach with multiple iterations. So the more iterations you do, the more better performance we would have. And we see that on like vision based benchmarks, we see pretty much our model obviously outperforms, whereas on math benchmarks we see, even though the task is pretty challenging, we see that the performance is pretty much on par with search based approaches. So VREST is a pretty competitive search-based approach. And for the test time scaling, we also like compare with test time scaling. So VREST is basically a self reward model, but we also have like a teacher reward to have like a fair comparison. Because in the search we use like a larger 32B model for the um, uh, final COT generations. So even with teacher reward of 32B in the search-based approach, we still outperform on various benchmarks, and compared to other benchmarks, we still outperform. And coming to the cost with respect to the test time scaling approaches, we see that on an average, we see of around 76% drop in the number of tokens that we use. And also, here is a simple ablation to see that at the importance of attention scores with respect to the performance on various benchmarks. We see there is a big gap in terms of the accuracy that we could achieve while using the attention scores, and also we can see here the performance of our model using ReaGEN compared to other baselines. We see that on various benchmarks we see that the performance is pretty superior. In some cases it's slightly equivalent, but yeah. So here are like some results, and we could try to find more results on the paper. And thank you for listening.